Welcome to Okonko Academy. In this tutorial, I'll be taking you guys through differential rules and some examples, and also how to differentiate line functions. Now, if you are new to this channel, I recommend that you please subscribe and put us on post notification. Now back to today's tutorial. I placed some regularly used functions or differentials here so that we get to know them, because they are used in almost every engineering equation encountered. So I want you guys to keep this in mind, some of these ones in mind. We will be proving some after we do the differential rules. But first of all, I would want to take us through how to differentiate the len function. Now suppose we have len of a function of f of x. Now f of x can be any function at all, maybe x plus 2, x squared plus 16, x cubed plus something, len of sine x, anything at all. So to find the derivative of this function, to find the derivative of this function with respect to x, what we do is that we differentiate the baby. I call this the baby, and the len function the parent. So bear with me. So we differentiate the baby. Then we divide it by the baby, right? So we differentiate what is inside, then we divide it by the original thing. So let's take an example. Let's say we have len of x squared plus 16 x squared plus 16. So with this, when we differentiate the inner one, when we differentiate this, we are going to get 2x, and we will divide it by the original function, which is x squared plus 16. So this is how to differentiate len, right? And also for differentiation of trig functions, let's say now we can see from this portion that when we have sine x and we are asked to differentiate, what do we get? We get cos x, right? So let's say we have sine 2x and we are asked to differentiate, what will it be? So the reason why for this we had cos x was that the coefficient of x was 1, right? The coefficient of x was 1. That's why, so we represented this as 1 times cos 1x, right? Yes. So because 1 times cos is the same as cos, you just write it like that. So when you are given a function like this, what you do is that you differentiate the baby, then you multiply it by the differentiation of the mother. So I've always said that the baby is what is inside. So the baby is what is inside, and the mother is what outside. So here 2x is the baby, so we differentiate the baby, we get 2. Then we multiply it by the differential of the mother. For trig functions, that's how we do it. We differentiate the baby, right? Then we multiply it by the mother. I said trig function, sorry. For sine and cos functions, so for sine and cos functions, we differentiate the baby, we multiply it by the differential of the mother. So when we differentiate the mother, what do we get? Cos 2x, right? Cos 2x. So that's how it's done. So when we differentiate sine 2x, you get 2 cos 2x. And you can do same for the rest. So differentiate cos 2x LMC. Please put your answer in the comment section. I will check and tell you if it is correct or not. So We will be solving some examples with what we've learnt right now. We'll be solving some examples. So let's solve this example. F of x is equal to x to the power 4 plus 6 sine, let's say 5x, because I want you guys to use what I just taught to do this. Learn 6x squared and learn 6x squared. Okay, so find find the differential of f of x. So first of all, the differential rule states that when you are given a function with this plus or minus, you can find the differential of this, you find the differential of this, you find the differentiation of this, then you add them, right? That will give you the differentiation of the whole expression. So we can find the differentiation of this. Now the differentiation of x to the power 4 will give you, so you use the 4 to multiply the expression, then subtract 1 from the power of 4, right? So we get 4 multiplying x to the power what? 3. So that's plus. Now 6 is a constant. Another differential rule is that when you have a multiplying, maybe a is a coefficient multiplying, let's say, a function that you want to differentiate, you can bring the function out. So you can bring the coefficient e, which is a constant, out, then you differentiate the function, right? You differentiate the function. So same as this one will be the same as the differentiation of the whole function. So you bring the coefficient out or the constant out, then you differentiate the function, then you multiply the two. Yes, so this will be the same thing. So these two, I'll bring the 6 out, then I'll differentiate this function sine 5x. So to differentiate sine 5x, now I'm writing sine 5x here. So to differentiate sine 5x, what do we do? First, we differentiate the baby, then you multiply the baby by the differential of the mother. You differentiate the baby, you multiply the differential of the baby by the differential of the mother. So when you differentiate the baby, which is 5x, you get 5, multiplied by the differential of sine, which will be what? Cos, positive cos. So cos 5x. So that will be the differential of sine 5x. So we are going to get 5 cos 5x. So that's minus. Now for ln 2 is going to be the same thing. Now what did I say for differentiating of ln? You differentiate the function inside divided by the original function. So we will do same for this. So we differentiate the function inside, right? When you differentiate 6x squared, what do we get? Now you know how to do this easily. So you get 6 times 2, which is 12, right? X, then you subtract minus 1 from the power of 2, so you get to the power 1. Yes, and that divided by the main expression, which is 6x squared. There will be some cancellations here. So here will be 4x cubed, 4x cubed plus 6 times 5 will give you 30 cos 5x minus 2 over x. Now we've solved this function. Also, we will be doing something we call product rule. Product rule of a differential equation. Product rule of a differential equation. Product rule. So sometimes we get a situation where multiplying the function through is very complicated, right? So let's say we have something like x squared plus 4x. This multiplied by 3x plus 6. Now some will say multiplying this, they might make mistakes. Let's make here minus so that multiplying it can be prone to mistakes. So maybe when you go and multiply this, you can make mistakes by maybe making a plus and getting the whole expression wrong. You could have multiplied this and you get a straight thing, then you just differentiate it simply. But we can also use the product rule to solve for this expression. You can also use the product rule to solve for this expression. So what the product rule says that when you have a function f of x multiplying a function g of x or g of y, anyhow put it, or f of y multiplying expression g of y, so anyhow you put it, you can differentiate this function by first of all keeping the original the first function, which is f of x, then differentiating, multiplying it by the differential of g of x, right, plus keeping the g of x and multiplying that by the differential of what, f of x. Now let's use this to solve an example. Let's say we are asked to differentiate this expression, right? So first of all, we keep this whole expression, which is x squared plus 4x. So that's right, this expression multiplied by differential of this expression. So differential of 3x minus 6 will give you, so when I differentiate 3x, I get 3. When I differentiate minus 6, I get 0, because here is the same as x to the power 0. So when I multiply 0 by 6, I get 0. So that's multiplied by 3, right? Plus g of x. Now g of x is 3x minus 6. And this is f of x, so differentiating f of x, I'm going to get 2x plus 4, right? I'm going to get 2x plus 4, so I multiply this expression by 2x plus 4. Then I simplify this expression. So I will leave this expression for you to simplify and also put the answer in the comment section. Now, let me just simplify. So when you simplify this, you are going to get 3x squared plus 12x plus, so with this I'm going to get 6x squared plus 12x minus 12x minus 24. So I'll get the final answer to be 9x squared plus 12x minus 24 as my final derivative of this expression. Again, we can also move to another rule called quotient rule. Quotient rule. Now for quotient rule, it's when we have a function, let's say f of x divided by g of x. divided by gen of x. Now I will be doing the real quotient rule in the next video, because this one involves a little bit of more technicalities and I don't want this video to be long. But for a teaser, I'll be teaching you a shortcut for some quotient rules for linear equations. So let's say I have f of x to be, let's say, 3x plus 2, right? And gen of x to be 6x plus 5. Let's say this expression is h of x, and I'm asked to find the differential of h of x. Now this is just a short trick so that I get to teach you the real concept behind the quotient rule. So what you do is that you multiply this 5 by this 3, then you subtract that, you multiply this 5 by this 3 minus this 6 by this 2, then you divide by the denominator squared. So this is going to be, it's going to be 5 times 3 minus 6 times 2, right? That's divided by 6x plus 5 squared. So this is the short trick. So you are going to get what? 15 minus 12 all divided by 6x plus 5 squared, right? Then we get our final answer to be 3 over 6x plus 5 all squared. Now thank you for watching this video to the end. Do well to like, comment and subscribe, and meet us in our new video for the quotient rule and other concepts of differentiability.